So, hello everyone. I am Indrajyoti Gaine. Presently, I am pursuing my PhD at IIT Kanpur from my Department of Mathematics and Statistics, and I am a PMRF fellow. And I have cleared UGC NET, UGC and CSR NET with 108 rank, All India 108 rank. Okay, so today we will start with the first chapter of class 11, that is set theory, and the basic of set theory is sets. So we will start our lecture with sets. So what are the sets? So sets are the basics of set theory. So what is set theory? Set theory is the branch of mathematical logic. Now, informally, one can think any collection as a set, like collection of all cars. Like for example, if I say collection of all two-wheelers, collection of all two-wheelers. Okay, so two-wheelers means it has exactly two wheels. So, we in this collection we are considering only those cars, those vehicles which have two wheels, but we can't include any four wheelers like it has four wheels, or any six wheelers like truck. So we are particularly collecting all those two wheelers. Again, for example, one can consider another example like student of all a school, or maybe a student of a class, like set collection of collection of collection of all students of class 11. So this is another collection. In this collection, we can only include those students who are reading in class 11. We can't include any student of class 10 or class 12. So this is a collection, and particularly these are called sets. So in particular, in this lecture, we are interested in mathematical objects, collecting all these mathematical objects. So for example, we can think of collection of all triangles. Collection of all triangles. Sorry. Collection of all triangles. So collection of all triangles means those geometrical figures which have three sides. So if I consider this the collection of all triangles, then it can include this kind of triangle. This can include this kind of triangle, or this kind of triangle. Like any figure, any geometrical figure with three sides, which satisfies the property of a triangle. But we can't include this geometrical object. We can't include this geometrical object because it has four sides and it is not a triangle, it is a square, or you can say it is a rectangle. So we are only collecting those geometrical figures which have three sides, or particularly it satisfies the properties of a triangle. So by these examples, we can say a set is a collection of objects. Okay, so we can claim that a set is a collection of objects. Okay, now the question is, any collection can be considered as a set. So let us find another example. We are considering set of all tall boys. For example, take set of all tall boys. Now the question is, who is the tall boy? Like if a guy has height for 5 feet, then a guy of height 5 feet 5 inch is taller for this guy. Again, if a guy has height 5.5 inch, then a guy with height 6 feet is taller than this. So there are nothing well defined parameter that this guy is taller and this guy is shorter. So it is comparatively, like if I compare with my height to another guy's height, then it can be we can compare that his height is much higher than me or lower than me. Like this, we are considering that this guy is taller or shorter than me. Okay, but this is not well defined. The point is that this is not well defined. For example, consider another example. Example 1. This is example 2. This is we are calling set of all renowned mathematicians. Now the question is this set of all renowned mathematicians. So this is totally prospective. Like one can think that this guy is a very renowned mathematician, but another guy can think that this guy is not a renowned mathematician. So this thing is not well defined. There is no parameter that after this parameter this guy is a renowned mathematician or not. So this thing is not well defined. So this definition, whatever we are claiming here, this claim is not totally correct. So we are missing something. So a set is a collection of, here we need something extra. A set is a collection of well defined objects. And what are the problem of these two examples? They are not well defined. They are not well defined. Okay. So what is the definition of a set? Definition of a set is a collection of well defined objects. Now these objects can be anything. This can be number, this can be geometrical figure, this can be any physical entity also. So in mathematics we are mainly concerned about the mathematical terms or numbers or mathematical or geometrical objects. So we are not worried about physical interpretation of those things. So only we are concerned about mathematical objects. So let us take a mathematical example. Okay. Example 3. So let us consider an example like set of all natural numbers. So this is one example. So which are natural numbers? Natural numbers are this 1, 2, 3, 4 and so on. Like we are adding 1, 1, 1, 1 and we are getting the numbers starting from 1 and ending to infinity. So this collection is the set of all natural numbers. Now if I make this collection and put in a second bracket, then it is called a set of natural numbers. So note that we write a set like this. In the second bracket, we include all elements of the set and we call this by a capital English letter which here we are denoting by this. This is the set of all natural numbers. Similarly, set of all integers like this. Z equals to -3, -2, -1, 0, 1, 2, 3, 4, and so on. So we are putting all those elements of the particular type in the second bracket and denoting this by a capital English letter. So in general, a set usually denoted by a capital letter, and the element of a set, here these are numbers, but usually a set, the elements of the set represented by small numbers. Like for example, if I denote like this, we can denote an example like this. A is a set. We denoting the set by A, which is the collection of A, B, C, D, E. So this should be capital letter, and this should be small letter. Okay. So up to this, we are almost clear about a set. So what are set? That is almost clear to us. Now there are many more examples, like a set of all prime numbers, set of all rivers of India. Like one can think of physical example like rivers of India, or set of all factors of 30. Like this, there are much more examples. Like one another example. Like okay, like one example 3, 4. Example 4. Example 4. That is prime factors of 210. So which are the prime factors of 210? Those are 2, 3, 5, and 7. That is, this number divides 210, and these numbers are prime. So these are the all collection of prime factors of 210. So put this in the second bracket, and we got the set of all prime factors. The set of all prime factors of this. Set of prime factors of 210, denoted by this. Okay. So till now we are almost clear about what are set. Now the thing is, if I denote this set by natural number n, for now it is denoted by just normal n, or it is z. Now the question is, the element 0. Just note the element 0. 0 is an element of this set. 0 is an element of this z set. But 0 is not an element of this set, this natural number set. So how can I denote this, that 0 is just element of this z, but 0 is not an element of this n? So for that, we use a Greek notation. That is, 0 belongs to z, but 0 doesn't belongs to n. So what is this notation? This notation called belongs to, and this notation called not belongs to. So 0 is belongs to z, but 0 does not belongs to n. Similarly, if I take an example like V is the set of all vowels. set of all vowels. Then V equals to A, sorry, A, E, I, O, U. So clearly A belongs to V, but B doesn't belong to V. Similarly, E belongs to V, but F doesn't belong to V. G doesn't belong to V. H doesn't belong to V. Okay, so thus we can consider that which elements are belong to this set and which elements are not belongs to this set. Okay, next, how we can represent a set? So there are two representation of a set. There are two method of representation of a set. How? One is roster or tabular form. Roster or tabular form. And another is set builder form. Okay, so roster or tabular form means already we gave one example. This example. See, we are particularly choosing elements A, E, I, O, U. These are the only elements of this set, and we are putting these elements inside a second bracket, and we are calling this a set of vowels. So this form is called the roster form, and this set is called the set builder form. So what is the roster form and what is set builder form? Let us define more clearly. So in the set builder form, you can see that we are writing a statement. We are writing a statement, a set of all vowels. So we are particularly defining some property that only this kind of elements can be included in this set. Okay, so we are defining a property. Like in our first example, we define two things: collection of all triangles. Collection of all triangles. So by this word, we are defining a particular type of geometrical objects. Okay, so only we can include those triangles. We can't include any figure which has two sides, or which has more than three sides. Like any geometrical figure with more than or less than three sides can't be included in this set. This only include those only have three figures, three sides. Okay, so this is called the set builder form. Like we are defining some property and we can allowing those kind of elements which are of this property. But in the roster form or tabular form, we can include those elements. Like we are writing all triangles and we are putting this in the inside second bracket, and we are calling it a roster form or tabular form. Like this set. This is the roster form. This is the roster form. Like this. This is the roster form. Okay. So let us define some more example of roster form. Example of roster form. Example of roster form. Okay. Example of roster form. Okay. So first example is set of all natural numbers natural numbers which divide 42. Which divide 42. So, okay, better is to consider a particular example and write it in roster and tabular from both. Roster and set builder from both. So, example of roster and set builder form. Okay, so set of natural number which divide 42. So if I denote is a roster form and tabular form, this is called roster form. Roster form and set builder form. So in roster form, we are denoting like this. We are denoting like this. Like which are the elements of this set? 1, 2, 3, 6, 7, 14, 21, 42. So this is the roster form. And what is set builder form? Set builder form is like this. N belongs to natural number such that N divides 42. So we are particularly defining some property and we are collecting those elements, and here we are giving elements. We are putting elements and putting this in the second bracket form. So this is the roster form and this is the set builder form. Okay. So take another example. Take another example B. Write solution of a equation of solution of this set of equations. Solution of the equation. Okay. Equation x minus 1 x square plus x minus 2 equal to 0. So if I solve it, we get the solutions x equals to 1 1 minus 2. Okay, we get three solutions like from x minus 1 and x square minus 2. If I solve it clearly, you can see like x minus 1 or this implies either x minus 1 equal to 0 or x square plus x minus 2 equal to 0. So this gives x equals to 1 and this gives x equals to 1 comma minus 2. Okay, so or we can also include this like for a clear interpretation. We can think this like not x minus 1, we can think it like x minus 5. So this thing should be much more clear. X minus 5 equal to 0, which implies x equals to 5. Okay, and this thing will give this. Okay, fine. Yeah, am I right or not? Okay, yeah. Okay, so we are getting three solutions: 1, 5, minus 2. So in tabular form or roster form, we are writing like this: 1, 5, minus 2. And in tabular form, we are writing like this: x such that x is a solution of the equation x minus 5 x square plus x minus 2 equal to 0. Okay, this is the called set builder form. Set builder Okay. So similarly, we can convert a roster form to set builder form, and we can convert a set builder form to roster form. So take one example. Like we have a set, say S. Example. Set is a set of X such that X is a positive integer and X square is less than 40. So this is clearly in set builder form. Now we want to translate it into roster form. So what will be the roster form? The roster form will be like this. So at first find which elements are in this set. So X is a positive integer and X square less than 40. So 1, because 1 is square less than 40. Then 2 square. 1 square less than 40. Okay. Then 2 square. This is also less than 40. So 2. Then 3 square. This is also less than 40. So 3. Then 4 square. 4 square is equal to 16. So less than 40. So 4 square is also less than 40. So 4. 5 square is 25. This is also less than 40. So 5. And 6 square. This is also less than 40. So 6. 7 square is 49. This is greater than 40. So we can't include 7 and so on. So these are all elements of this set S. So in roster form, we will write like this. 1, 2, 3, 4, 5, 6. This is the roster form. So thus we can convert Thus we can convert set builder form to roster form. Roster form. Similarly, take another example. This is example 1 and example 2. Next one is example 2. So let us say this 1, 4, 9, 16, 25 and so on. Okay, so how can I write this in set builder form? This is clearly roster form. By previous example, we are clear that this is a roster form. So we need to convert it into set builder form. Need to convert it into set builder form. So how can I convert it into set builder form? So see this. The first one is 1 square, then 2 square, then 3 square, then 4 square, then 5 square. Okay, so only square elements are included. So how can I define this? Like a equals to n square such that n belongs to natural number. Or not belongs to, just you can write n is a natural number. N is a natural number. Okay, so this is our set builder form. Take another example of set builder form. I mean roster form to set builder form. Let us set be this 1 by 2, 2 by 3, 3 by 4, 4 by 5, 5 by 6, and so on. So I need to convert it into set builder form again. So observe one thing, that this denominator and denominator is 1 greater than the numerator. That is, numerator is 1 less than the denominator. So in set builder form, we can write it like this: n by n plus 1, such that n is a natural number. Okay, so this is our set builder form. Okay, so thus we can do a few examples, and you can try from the exercise. Many questions are there. You can do it yourself, or we can do another one example. Like okay, first let's take one example. Okay, so another example is the example 5.1. That is the set of all natural numbers. A is x, such that x is an odd natural number. So clearly this is x has two property. I mean, we are allowing only those elements from natural number which are odd. Like two property. First, natural number. Second, odd. So, which are the elements of this set A? First of all, odd means 1, 3, 5, 7, 9, 11, and so on. Like which elements are odd and belongs to this natural number set. Those elements can be included in this set. So in roster form, this is, we can put in the second bracket and we can call it A. This is our roster form. And this is our set builder form. Roster form, and this is our set builder form. Okay. Okay. So now come to one particular example. Let us write an example of a set A with a x, where x is a student of class 11 presently studying in your school. Presently studying in your school. Okay, so you can clearly count your batchmates. Number of batchmates, there will be some 40 students in your classroom. It can be 40, 50, and then it depends on your classroom and your school. So this is count. This is our total count of students. So how can I define this number? So this number is denoted like n of A. N of A. That is, how many elements are there present in this set A is denoted by N. So what N stands for? N stands for the number of elements present in the set A. Number of elements present in the set A. Okay, so clearly this set has numbers maybe 40, 50. Okay, take another example like B. This set of all vowels. Set of all vowels. That is, the set A, E, I, O, U. Then what will be n of V? That is equals to 5. So we can count this set. So now take another example like W. W is the, so not W, say N. Say N. Or there are any better example? Okay. Okay. G. Set of all points on a line. Okay. So which are the set of all points of a line? So let us draw a line. Let's say this is our line. Okay. And by blue dot, we are denoting a point. Like this is a point. This is a point. This is a point. This is a point. This is a point, and so on. So how many points are there in this state G? One can say, sir, we can see only five points there. So only 5 points are there. So why this is not a point? Why this is not a point? So all these are points of this set. So if I consider the set of all points on a line, so this set is uncountable. You can't count the number of points or how many points are there. So clearly the number of elements of this set is infinite, which we denote by like this sign. This is the sign of infinity, and we define n of G equals to infinite. So if a set has finite, I mean not infinite number of elements, then that set is called finite. Okay, so what are finite set and infinite set? So the definition is like, okay, finite set. If a set consists of a definite number of elements, then it is called finite set. And what is infinite set? Infinite set, that is, if a set is not finite, then it is called infinite set. Okay. Now the question is, if I consider a set like this, set of all natural numbers x such that x is a natural number. Okay, not like this. This set is not like this. Let's take an example B. Like x square equals to 4 and x is odd. Okay, so we put two conditions to include elements in this set. So in the set B, which elements are there? So if I solve this equation, like x square equals to 4, then clearly one can say x equals to plus minus 2. plus minus 2. Now we have another condition. We have another condition that x is odd. So we can't include this plus minus 2 in the set B. So what is the set B? The B set has no element in this set. Okay, the B set consists of no element. So this B, the set B consists of no element. So this set is called the empty set or null set or void set. So what is the null set or empty set or void set? What can I say? Okay. So null set. Null set is a set which does not contain any element is called a null set or void set or empty set. Okay, so this is the definition of a null set, and one example is given here. So B is our null set. The example B, so B is a null set. Okay, so B is our a null set. So take another example of null set. Say C. C with the set of all natural number x, right? Such that not like this. Such that 1 less than x less than 2 and x is a natural number. Okay, so C is a set which consists of these elements. Now, which are the elements between 1 and 2? Is there a natural number which belongs to 1 and between 1 and 2? No, there are no natural number in between 1 and 2. So this set is a void set or empty set or natural or null set. So we denote it by this. We denote a null set by this notation. So phi is the notation. This is called phi. Phi denotes the set is empty. Okay. So the question one can question that there are three kinds of state, right? Like whatever we have claimed, we just now we get introduced with three sets: finite set, infinite set, null set. Now the question is, can I say the null set is finite set or null set is infinite set, or we can't claim anything? So the answer is, clear-cut answer is, null set is considered as a finite set. Why? Because by definition, we are defining infinite set which has infinitely many elements. A infinite set is a set which consists of infinitely many elements. So we can modify this statement, or we can rewrite another statement like this. In statement 1, statement 2 is an infinite set. Infinite set consists infinitely many elements. So an infinite set is the set which consists of infinitely many elements. Okay. Now the set null set. Come to the null set. So null set consists no element. So how can I claim that this set contains infinitely many elements? So this is a finite set. So in case of finite set consists of all those elements which has finitely many elements or no element. So if I say finite set, this consists of those sets. Set with no element or finitely many element. That is, number of this set should be less than infinity. Or infinite set is like infinite set is those set with infinitely many elements, like Na should be equals to infinity. And okay, so one remark. An infinite set cannot be always written as a roster form. All infinite set cannot be described in roster form. For example, if I consider set of all real numbers, okay, so set of all real numbers, we denote it by R, set of all real numbers. Okay, so set of all real numbers means all those sets which are real. Okay, so this set consists of, we can write this as a set builder from like X, such that X is a real number. Okay, but how can I write this in a roster form? If anyone asks like to write this set as a roster form, so how can one write? Like we are including 1, 2, 3, 4. Okay, 0, -1, -2. Okay, we can include 1/2, 1/3, 1/4. We can include √2, √3, √5, all those things. But the problem is we don't know all elements. Like in real number set, there are lots of elements. Lots of means we can't even count, or we can't even know that which elements are after which. So we can't write it in a roster form. We can't explain this in a roster form, because in roster form, one particular remark is this, that one in roster form we know the elements. We are defining the exact elements. We have a pattern, and only this pattern will be included in this set. But if for real number, if I say the set of all real numbers, then we have no pattern to represent the roster form. Like in second bracket, we are including some of the elements of the set, but we can't include all elements or all form of the elements. Like there are different form of elements in the real number set. So that's why we can't represent this infinite set real number into roster form. So for this reason, This remark is very important that all infinite set cannot be described in roster form. So today's lecture we will stop here. Next day we will continue from here.